Microphone, oops. Yep. Let's see if that's where it is here. It's 107. All right. So what I want you to do, this is either on page 113 or on page 107. All right? Part B. Do you see those systems of equations there? Do y'all see them? Okay, I want you to practice solving those systems. I recommend you try both methods, and for each one, kind of pick which method you thought was better, because you have to be able to use them both. I think on the exam, I'm not going to force you to use one or the other. I'm going to let you pick, but as you can see, like on this problem on a test, you want to go with the more efficient one, right? If this had been, to start the problem, if this had been like this, I might have done the first method, because x is already by itself. Like, you just have to move the 5y over. All right. Now, we're going to proceed. The only way to get good at that is to practice, so I'll let you do that at home. And now, I want to talk about some applications of this. Yeah, I'll collect that as a quiz grade. Why don't you turn that in next time, okay? You can clean it up and then you can turn it in next time for a quiz grade. All right, fair? It's really more just going to be an you attempted it, right? But now you can go home and finish it up. We'll start with something pretty I'm not going to say basic, but like, this doesn't seem like very useful, all right? Let's say you have $180 in your pocket. You have $5 and $10 bills only. There's a lot of ways that you could have $180 with $5 and $10 bills, right? But I'm going to tell you that you have exactly 21 bills in your pocket. How many 5s and how many 10s do you have? Understand the question? You have $180 in your pocket. All you have are $5 and $10 bills. You have 21 bills total. How many of them are 5s? How many of them are 10s? Somehow, some way, this is a system of linear equations. So I'm going to first start by assigning variables, x and y. I'm going to let x be equal to the number of 5s we have, okay? I'm going to let y be the number of 10s we have. Do you all agree with me that all I need to figure out is what x is and what y is? And I'm done? Okay, can you give me any information about the number of 5s I have and the number of 10s I have? They add up to 21, right? So if I write down x plus y, this must be 21. Because remember, x is the number of bills I have, right? However many 5s I have plus however many 10s I have, that has to total 21. What other information do I have? I have actually $180, right? So how much of that would be from the 5s? Let's see. Yeah. So however many 5s I have, right? I multiply that times 5, and that's how much money it would be. However many 10s I have, I multiply that by 10, and that would be how much I have in value from the $10 bills. That has to total to be 180. So the second equation I can come up with would look like this. 5 times x plus 10 times y must be 180. It's very important that you understand the interpretation of this. How many 5s I have times 5. How many 10s I have times 10 would be my total amount of money that I have in my pocket, which would be 180. Got it? system of equations. Pardon?
15 tenths and 6 fives.
Is that what it is? So you doing that just mentally? Yeah. This is a problem where you could probably do it mentally if you spent enough time. But if I change that to like, $1,800 and, I don't know, 63 bills, it might be harder, right? So this is just kind of like get us used to the idea of a word problem. Trust me, the next one I give you, you won't be able to do. Not in your head. All right, so how would you like to go about solving this? You think method 1, method 2? What do you think? Y'all like 2? 1? See, this is your call. I think I'm going to go with 2. Just because, look, I can make the 5x go away by doing what? Multiplying this by -5. I could make the 10y go away by multiplying that by -10. I'd rather do that than start to move, like solve and move things around. That's my preference right now, just looking at the problem. I'm going to go -5 on the first equation. I'm going to rewrite it. So pass it through. Your new system of equations will be what? -5x minus 5y equals -105. And then the bottom is 5x plus 10y equals 180. And then we add down, straight down, and we get 0, and then how many y's? 5 y's. And -105, add 180, 75. And divide through by 5. Y is 25. No. What am I doing? 15? No. Y is 15. Once you know what y is, what do? Plug it back into any equation you want. I'm going to go back. This is a nice one. Doesn't that look like a real nice equation to work with? So I'm going to write down x plus y is 21. And I know that y is 15. Subtracting 15 on both sides, 6. 6 $5 bills, 15 $10 bills, right? So I have 6 5s and 15 10s. So 15 10s would be $150. And 6 5s would be 30, and you add them together, right? And you got your 180. Here's a question. Is there any other way that you could do it? That you could have $180 in your pocket with $5 and $10 bills only, have 21 bills, and have the 180? Is there any other way? Probably? What do y'all think? No, it's impossible.
You give a certain amount of bills.
Yeah, because look, what we're saying is that the only way that these two are simultaneously solved is if x is 6 and y is 15. These are two lines, right? Two lines can only hit each other once, right? There's only one point that they can hit each other. So there is no other combination that you can have of bills that will satisfy these two. Now, of course, you could have $180 in your pocket with 5s and 10s if you take out the 21 bill restriction, right? Then you could do it. But if it has to be 21 bills, has to be $180, only 5s and 10s, that's the only way to do it. Got it? So you could almost look at this as being like you're eliminating an infinite number of other combinations. Like this is the only one that will work. You don't even have to think about any others that could. All right. Try something different. I talked about this way back when we were doing conversions. That if you go to a chemistry lab and you take a chemistry course, and you have to come up with some solution that they don't have like every concentration of every solution like in the back storage room somewhere. They have these set concentrations, and then they use those to create whatever they need for the experiment. And I'm going to do a problem like that right now. All right, so let's say we have, you have a supply of 5% saline. Is that right? Saline? That doesn't look right. Okay, sometimes I just, I don't know. You know how you look at things, words sometimes, and you're just like, okay. You have a supply of 5% saline and 30% saline. So I like pictures, so I'm going to draw a picture for you real quick. Here's the little chemistry lab. There's a little door, and back here in this little room, they've got these two vats of 5% and 30% solution back here. They're behind locked doors because all the students are out here on their little desks. They're going to run their experiments, right? So someone's got to run to the back and get these two things, and they're going to mix them together. And what we want is this. You need 5 liters of 17% saline. That's what I need to make. Now imagine these vats are big, okay? So I've got an unlimited supply of this stuff, okay? So that way we don't have to argue about, oh, well, what if you don't have that much? Okay, I've got plenty of that stuff back there. How much of each should I mix together? Do you all understand the problem? You understand what I'm trying to do? Got to go back there, mix those two together to get exactly a 17% solution. 5 liters, dead on 5 liters. If I do all 5 liters, the 30% solution, then I'm going to have a 30% solution, right? If I do all 5 liters 5%, it's going to be a 5%. Somewhere in the middle, right? Somewhere is this point where I would be at a 17% mixture. All right, so what did I say we did in the last problem? The first step was to assign the variables. So let's use x and y. X is going to be equal to something, y is going to be equal to something. You tell me. Is what? 30%. How do you want me to write that? I agree, that's fine, but look, in the last one, x was the number of $5 bills, right? And y was the number of $10 bills. What are we being asked for here? How much, right? The quantity, the liters, right? So x should be the number of liters of what? The 5% or the 30. It doesn't matter which one you want. So how about I just make sure I'm clear on it. This x is going to be equal to the number of liters of the 5%. And then y will be the number of liters of 30%. Yeah? Let's try and set up the equation. The equations. Can anyone tell me one of the equations? X plus y is 5. However many liters of the 5% plus however many liters of the 30%, when you put those together, you have to get 5 liters, right? Here's the most complicated part, all right? The second equation. I want you to look at the vat of our 5-liter mixture when we're done. Here's our 5 liters, right? It's all mixed up, it's all been done. How much of that is salt? How much, I mean, yeah, salt, we're using saline. How much salt is in there? 17%, right? So if I were to come in here and I were to be able to separate the salt here, it's 17%. So can you tell me how many liters that is? How many liters of salt you have? How would you do that? How could you tell me 17% of this, right, is salt? So you're going to do 0.17 times 5, which is, what is it? 0.85? Does that make sense? When you do your mixture at the end, that's how much salt is in there. Yeah? Yes? Yes? That's the end result salt. How much of this salt came from the 5%? You don't know, do you? How much of that salt came from the 30%? You don't know, but that's what you need to figure out, right? So our last equation here has to do with the salt. This has to do with the total amount of liquid. This is the salt part of it. The end result is how many liters of salt? 0.85, right? 0.85? Now, how much of this stuff will be salt? What's the percent on it? 5%, right? So I could put 0.05 times x. So however much of the x I put in, the 5% I put in, that's how much of it is salt. Just like over here, right? 17% of 5 was how much salt we had at the end. 5% of x is how much salt comes from that, I erased them, you know, that comes from that first container. Plus, how much salt comes from this one? 30%, 0.30 y. Those two together added up have to equal the total amount of salt we have at the end, which is 0.85. Clear? That's it. That's your system. Now, we don't like those decimals, do we? But this is a system of equations, and we can always multiply both sides of any equation by any number. So why don't we get rid of those decimals? How could you get rid of 0.05, 0.30, 0.85 and make them all nice numbers? Multiply by 100, right? 100 will move the decimal point over twice. So I'm going to just start with that, 100, and I get a new system. It looks like this, 5x plus 30y, be careful there, equals 85. And then x plus y is 5. That's the same system. What are the big mistakes I see on this? I see people set this equation up like this, but instead of putting 0.85 here, what do you think they put? 0.17. They forget to multiply times the 5 to figure out how much of it is. Yes, it's 17%, but 70% of 5 liters is this much. Is that a question? Okay. All right, so now, how would you like to go about this one? Yeah, it looks like the second method again looks pretty clean on this, doesn't it? Yes?
So you can multiply the equations twice?
Oh yeah. Oh yeah. You can multiply it as many times as you need. Because all it's doing is just, balance, like, you have a balance, you put 5 pounds on each side, still balanced. Then you come in and put 100 pounds on each side, still balanced. As long as you do same thing both sides, you can do unlimited number. All right, here we go. Multiplying the second equation by what? -5. Could I have done -30? Yeah, and that would have killed off the y's. It doesn't matter which way you do it. Rewrite the system. 5x plus 30y equals 85. And -5x minus 5y equals -25. Add down. What do you get? 25y equals 60. And divide through. We're going to get a decimal here. Go ahead and give me the decimal. 2.4? All right. And to get x, we can replace this y into any of these equations, right? I like this one, nice and clean. So I'm going to replace that now. X plus y is 5. X plus 2.4 is 5. X is what? 2.6. I thought it was, yeah, I thought it was going to come out to be uglier decimals, actually. I thought it was going to not, I thought it was going to be like 2.4327, you know, like I didn't realize, I made up the problem, so I didn't realize it was going to turn out so nice. I thought we were going to have to round it. We didn't. Yeah. So let's summarize. We're gonna take 2.6. To make this happen, we're going to take 2.6 what? Liters of the 5%. We're going to mix it with 2.4 liters of the 30%. And when we're done, we should have a 5-liter container of 17% saline. See, that would be harder to do in your head, right? You know what I'm saying? All right, I'm going to put something else up here. The word problems for the homework. Let me tell you about the word problems. It's part C for the homework. Do y'all see a part C there? Can I see your part C? Just to make sure. Tree, does it go to the other side?
Yeah.
Okay. Okay, yeah, you're just going to have to mess with all those. And maybe we can entertain some questions on that next class. Any questions that you might have on that homework? I'm going to put a system up here. (2x minus y equals 10). Negative 4x plus 2y equals 1. I just want you to see that this is a kind of a unique example here. If you were to do this, how would you approach it? Yeah, so how would you do this? You'd multiply, you can do method 2? Multiply the top one by 2? That'll make these two cancel, won't it? And when you rewrite the system, you get 4x minus 2y equals 20. And then on this bottom one, negative 4x plus 2y equals 1. And when you add down, something happens, right? Here, gone. Here, gone. So what's on the left side of your equation? 0. And the right side of the equation? 21. 0 doesn't equal 21, right? What does this mean? Something's wrong. Something went bad. Think about what this represents. What did you say? I didn't hear you. Okay. Yes. Think of it geometrically. When I first started this whole topic today, I started by doing L1, L2 and drawing you two lines, right? Close, not quite. They're parallel lines. These lines don't hit each other. Right? Wasn't this trying to find the intersection of two lines? And so what's happening here is that we have a line and we have another line and they're parallel. and they don't intersect each other. Yes?
Didn't you have a question on one of the tests that said parallel lines always intersect at some point?
That's right. It was false. They don't intersect always. In two-dimensional Euclidean flat sheet of paper, they never intersect. But in perspective geometry, which is the geometry that artists use, they do. I talked about it in class for like 20 minutes, so that's why it was a bonus question. Drew pictures, yep. All right, so does this make sense? If you get something that makes absolutely no sense at all, then it means that the two lines are parallel. Okay, I'm going to tweak it just a little bit. Same problem. I changed this to a negative 20. You would do the same thing, right? Multiply this by 2. Go across. You would get 4x minus 2y equals 20. And then negative 4x plus 2y equals negative 20. And when you add straight down, what do you get this time? 0 equals 0. Now that's true. The other one was 0 was equal to 21 or something. That didn't make any sense. This makes sense, doesn't it? Now what does this mean? Same line. It's the same line. These two lines are identical. So it's like you're saying, when does this line intersect with this line? All the time. So every point that satisfies one of those equations would satisfy the other equation because they're the same line. So there's an infinite number of intersection points. So the answer to this problem, you would just say, infinite solutions. On the other one, you would say no solutions.
Did you put undefined too?
It is defined as no solution. Undefined would be like trying to divide by 0. That's undefined. So your solution, you just say no solution. What I would do on a test is just kind of like give you something like this, and I would hope that at this point you would say same line or infinite solutions. If you had 0 equals 21, you would say parallel lines or no solution, something like that. And then there's only 3 cases that could ever happen. 2 lines either hit each other at one point, they're parallel, they never hit, or they're the same line, right? Those are the only 3 possibilities. All right, we have about 15 minutes, right? This is actually a pretty good, stopping point? Is that what you said? Mm-hmm. It is actually a really good stopping point. I just want to make sure there's nothing on the homework that boxes are purchased on. I think that is. So I have a question for you. You can start packing up. We'll call it a day. I don't have a sign-in sheet today. So what we'll do